about your favorite type of ice cream. Think in your mind your favorite type of ice cream. Whisper your name what your favorite kind of ice cream is. Okay, I need all eyes up here in 3, 2, 1, and 0. Show me your fingers. How many scoops of ice cream could you eat right now? How many scoops of ice cream? Laura has so many, and Japheth is like, I could do this many. I have realistic people like Lexi and Logan who are like, I can eat 3, Hannah 4. Okay. All right, 5. Isaac's doing 5. Okay. And my friends that are doing this, you are such liars. You cannot eat that much ice cream. Oh, okay. Okay, I need all eyes up here in 3, 2, 1, and 0. So we are going to think about our scoops of ice cream. And I really like Isaac, his version. He said he can have 5 scoops of ice cream. I went to Leatherby's last weekend. Hello. Oh, I'm so glad that so many of my friends went. And I got a sundae, and I felt like it had 5 scoops in it. Okay. So 5 scoops of ice cream. And then Mrs. Thayer decided that not only is everyone in here getting 5 scoops of ice cream, but we're going to do it during 5 class periods. What? So for 5 class periods, everyone's getting 5 scoops of ice cream? That's a lot of ice cream, right? Yeah. But then your mom wrote to the school and she said, do you know what? I think that my 6th graders are so awesome that they should get 5 scoops of ice cream in 5 class periods for 5 days straight. Oh my gosh, who wants that story to be true? It's not, but that would be cool though. Oh, so sad. Okay. Hey, I still need everyone with me. Okay. So the word exponent, okay, the exponent, it's a number that tells you how many times a base is used as a repeating factor. Okay? So we're going to take this, our ice cream scoop story, 5 scoops of ice cream in 5 class periods for 5 days. And we're going to rewrite this with a base and with an exponent. So we're going to write this when my base is 5. The number I'm seeing up here is 5. That's the base. So we're going to draw an arrow, write the word base so that we know. You are welcome to write this down. And then we're going to put a tiny 3 up here because we see the 5 showing up 1, 2, 3 times. And this 3 is the exponent. Okay? So basically, an exponent, it's creating less writing for you. We can say it's 5 to the 3rd power, or we can say it's 5 times 5 times 5. Whatever way you look at it, you're still going to come out with the same answer. These two are the same, 5 times 5 times 5, and then 5 to the 3rd power, they're the same. Okay, this is what an exponent is. So I want to know how many scoops of ice cream we'd get during the week if this were true. Think in your mind, what is 5 times 5? Think it in your mind. Say it out loud. 25. 25. 5 times 5 is 25. And then we're going to do 25 times 5. 5 times 5 is 25. Carry my 2. 5 times 2 is 10. Plus 2 is what? 12. 12. How many scoops of ice cream would we get? 125. 125.
We should do that.
Raise your hand if we're writing a letter to moms and dads and Mrs. Timothy and your 6th grade teacher about 125 scoops of ice cream. Yeah, right? Hey, so today, I still need you with me, friends. Thank you. So today we're going to be working with exponents. And so I do need your math journal to match my math journal. And right underneath this, we're still working on the side, I'm going to give you the base and the exponent. Before we move on, tell your partner which one is the base and which one is the exponent. Okay, I need all eyes up here in 3, 2, 1, and 0. Thank you. Oh, are you doing class points?
Yeah. No.
Do you have a board?
We should have a board, but keep track of it, but we don't like the board.
Yeah, it's at the class. It's in the class.
Well, when you get back to class, like I'm doing points for you.
Okay.
We'll chat. Okay. Thank you for being with me. Okay, so I have 6 to the 2nd power. What's another way of writing this? It would be what times what? Tell your partner right now.
6.
Okay, yeah. So it's gonna be 6 times 6. So 6 to the 2nd power is, what does it equal?
36.
36. Beautiful. Okay. Exponents. It should be a review. It's something that should have been talked about a little bit in 5th grade. Yeah, so exponents, okay? Once your math journal matches my math journal, we're going to move down right underneath our green paper. Okay, right underneath our green paper. And I am going to give you an exponent. I'm going to give you a base number and an exponent. And with your partner, I want you to actually solve it. Okay? So I have 4 to the 3rd power. So with your partner, go ahead and solve this. Set it up however you would solve it.
Wait, is it because you want us to solve it?
Yep, go ahead and solve it. Go ahead and solve it.
Got it.
Okay, I need all eyes up here in 3, 2, 1, and 0. Thanks for being with me, friends. So a mistake that I see students do frequently is they'll see 4 to the 3rd power. 4 times 3 is 12. Is my answer 12?
No.
No, it's not, right? So really, what 4 times 4, or I apologize, what 4 to the 3rd power means, it's actually 4 times 4 times 4, right?
Yeah.
Yeah. And so we're going to solve that. 4 times 4 is what?
16.
16, and I don't know what 16 times 4 is. So I'm actually going to do a little bit of math on the side, and that's okay because we know that we can do that. 4 times 6 is what?
24.
24. Carry my 2. 4 times 1?
4.
Plus 2?
6.
Good. So 4 times 4 times 4 equals what, friends?
64.
64. So 4 to the 3rd power is what? 64. Good. Dakota.
You could have just cut the 4 in half, made it 32, and then add 32.
That wouldn't be as strong.
Cut the 4 in half.
So make it 2.
Oh, I see. Yes, that is one way that you can do it. Very nice, my dear. Okay. On the side, I am going to show you guys. I want to show you guys something. Okay. If I have 10 to the 1st power, it's actually going to equal 10. Okay. Because it's 10 times nothing. Like it's just not times 0. It's 10. Like we're just leaving it as 10. Okay. So 19 to the 1st power equals 19. And tell your partner what 201 to the 1st power equals. Yeah, 201. Good. Okay. So with exponents, which is what 7.1 is about, remember that it's just a way where we have our base number, and then we know that it's going to be how many times the base number is being multiplied by itself with a tiny number that goes up top. Does that make sense?
Yeah.
Okay, awesome. Addison, go ahead and close that one.